Hello, welcome back. Here we're going to look at rational algebraic fractions. On our discussion of arithmetic, we had that if we have 2 over 3 and we had to add it to 1 over 2, all we had to do was look for the LCM of 3 and 2, which would donate as 6, and then 3 divided by 6 will give us 2. Use that 2 to multiply the 2 above here. We get 4. We put the plus sign. 2 divided by 6 is 3. 3 multiplied by 1, 3. And then what this will give us is 7 over 6, which should be write as 1 whole number 1 over 6. This is how this is simplified. But then if we had A over B plus C over D, one quick way to look for the sum of B and D is to multiply B and D together. So we will have BD multiplied together. Then A would then divide BD. Sorry, B would then divide BD. If BD is divided by B, the B's will cancel. So D has to multiply A, and we will have AD here. Plus, then D would then have to divide BD, of which if BD is divided by D, the D's will cancel and B here. B has to multiply C. This is have BC. So this work we have done here and this one we did, and this work here and this work here, they are essentially the same thing. Only difference being the one on the left part has to do with numbers, while on the right part we had algebraic expressions. And then just like we discussed before, this AD and BC, we cannot add them together because they are not like terms. They do not like this is AD, but this is not AD again. So they are not like terms, so they cannot be added. They can be left this way. Neither can they be factored. They don't have a common term in them here. So this is the simplest way we can go with this expression. So if we are asked to simplify an expression involving algebraic symbols, the step to take is not as different as we take when we are simplifying fraction. Only difference being that we cannot add some terms because they are not like terms. Let's say, for example, we are asked to simplify this expression 2x over 1 plus x, then plus x, x, then all divided by 1 minus x. Here, the LCM is you have to multiply these two together. So this is 1 plus x. No, sorry about that. This is 1 plus x multiplying 1 minus x. And then too big. And then here, 1 plus x multiplied by 1 minus x has to be divided by 1 plus x, of which they will both cancel out. So this is 2x. We then multiply 1 minus x. Then we put a plus sign here. Here now x, for the x part, 1 minus x has to divide 1 plus x multiplied by 1 minus x, of which 1 minus x will cancel out. So this will be x multiplied by 1 plus x. What we'll have last is that 2x multiply 1 to give us 2x. And then 2x multiply negative x. Then this will be negative 2x squared because you have x multiplying x, and by this is x to the power of 2. The negative sign is there. Plus of this is x. Then this is plus x squared because x is multiplying itself twice, all divided by 1 plus x divided by multiplied by 1 minus x. So if we proceed further here, what this will give us is 2x added to x is 3x, and then negative 2x squared plus x squared all over 1 plus x 1 minus x. Now this is negative 2, this is positive 1. The coefficient, this will give us negative x squared. So this is 3x minus x squared all over. Now the denominator part here, we can write this as 1 minus x squared, because as I have said in the previous videos, there's a formula called difference of squares formula, and it says that 1 minus x 1 plus x will give you just like 1 minus x squared, and we have verified this twice in the previous videos, which you can verify yourself by multiplying out, or you should just check through the videos and see the previous things we did here. So here now we can simply bring out x in numerator. We bring out x, we get 3 minus x all divided by 1 minus x squared. So this is the simplest way we can leave this expression. Notice that we cannot add 3x and negative x squared. The reason we cannot do that is because they are not of like terms, because here x is x to the first power and this place is now x to the second power. They are not of like terms, so they cannot be added together. But this is the simplest form the answer can get, and we have to stop at this point here. Of course, in the coming videos, I'm going to solve harder examples on algebraic fractions. If you like my content, please subscribe to my channel for more interesting mathematical stuffs, and also like the video if you like the video. Thank you for your time. Have a nice day.